Next up, we have quadratic equations and functions. And you might be asking, what's the difference between the two? I have no idea. Like, on College Board, if you look at the questions, one says it's quadratic equations, and the other one says it's nonlinear functions. Like, what? I think equations, you solve for x, and then the functions, you look at the graph. But I don't know. Anyways, let's get started. First, the standard form for quadratic equations is f of x is equal to ax squared plus bx plus c. And there's two things you can get from that alone. The first one is that the sum of the solutions is negative b over a. So if you found your solutions and added them together, that would be negative b over a. And the second thing is that the product of the solutions is equal to c over a. So if you took your solutions and multiplied them together, you would get c over a. Here I have an example, and we're gonna go ahead and use those two little tricks to find the sum and the product without factoring it out or solving for x or using Desmos. So first, we know that the sum of the solutions is negative b over a. And here, b is 5 and a is 1. Remember, if it's just x by itself, technically there's like an imaginary 1 in front of it. So negative b over a would be negative 5 over 1. And then we know that the product of the solutions is c over a. Here, c is 4 and a is 1. So that would be 4 over 1. Here I am on Desmos, and I went ahead and typed in our equation just to show you that it works. First things first, we know that our solutions will be negative 4 and negative 1. And if we go ahead and add those together, we get that the sum is negative 5, which is the same as what we got using our shortcut. And then, if we go ahead and multiply these together, we get that the product is positive 4, which is also the same as what we got using our shortcut. Whether you use Desmos or the shortcut, both of them will get you the right answer, so just use whatever is more comfortable for you. But I'm not gonna lie, personally I'll use the shortcut because it takes a lot less time than just typing it in. Moving on, we have factoring, and I was thinking for a really long time whether if I wanted to show how to solve quadratic equations by hand, and then I realized that I hate factoring. Like, there's no point, just put it in Desmos. 100% of the time, it's gonna be easier to just use Desmos. And then you have the quadratic formula, and that one's also just way too long to write out, so just use Desmos. Anyways, there are a few mental shortcuts that I want to point out. The first one is the perfect square trinomial. So here, this states that a plus b squared is equal to a squared plus 2ab plus b squared, and a minus b squared is equal to a squared minus 2ab plus b squared. The difference between the two is that if you're subtracting here, the only thing that changes is that this very first sign becomes a minus sign. So here I have an example, and we're gonna go ahead and expand this without foiling at all. We know that x plus 5 squared, which is just the same as a plus b squared, is equal to a squared plus 2ab plus b squared. X, which is our first term, is going to be our a, and 5, which is our second term, is going to be our b. So if we plug that in, a squared is going to be x squared plus 2 times a, which is x, and b, which is 5, plus b squared, which is 5 squared. Then if we go ahead and simplify this, we get that x squared still stays the same, plus 2 times x times 5, that's going to be 10x, and then 5 squared is going to be 25. So x plus 5 squared is equal to x squared plus 10x plus 25. And we did all of that without needing to FOIL at all. Here I am on Desmos, and I went ahead and plugged in our two expressions, x plus 5 squared and x squared plus 10x plus 25. And you can see that these two graphs are the exact same, which means that these two are equal. Now, you could just plug this in from the start and know that they're equal, or you could, if you're good at mental math, go ahead and do that little shortcut. Here I have another example, but this time we're going to be subtracting. X minus 7 squared is the same as a minus b squared, and we know that that's equal to a squared minus 2ab plus b squared. x, which is our first term, is going to be our a, and 7, which is our second term, is going to be our b. That means that a squared is x squared minus 2 times a, which is x, times b, which is 7, plus b squared, which is 7 squared. And if we go ahead and simplify that, x squared stays the same, minus 2 times x times 7, which is 14x, plus 7 squared, which is 49. That means that x minus 7 squared is equal to x squared minus 14x plus 49. Now, the important thing to notice here is that whenever you're substituting in for b, you only need to put in this number right here. You don't need to include the minus sign here. So don't think that whenever you're substituting it in, it should be a negative, right? Because we already accounted that with this minus sign right here. Here I am on Desmos, and I went ahead and plugged in our two expressions once again. And you can see that the two graphs are the same, they're on top of each other, which means that they're equal. So if you want to use the little shortcut, or if you want to put in Desmos, it doesn't really matter. I mean, unless they ask you to FOIL it, then you could use it. For our next shortcut, we have difference of two squares. And this states that a squared minus b squared is equal to a plus b times a minus b. Here I have an example of 4x squared minus 9, which is the same as a squared minus b squared. And we know that's going to be equal to a plus b times a minus b. Now first, let's find out what our a is. We know that a squared is equal to 4x squared, and if we go ahead and take the square root of both sides, we get that a is equal to 2x. And then for b, we know that b squared is equal to 9, and if we take the square root of both sides, we get that b is equal to 3. Now we know that 4x squared minus 9 is equal to 2x plus 3 times 2x minus 3. And just like the perfect square trinomial, whenever you're substituting in for b, you don't need to include this minus sign right here, so don't think that b should be a negative, because we already included for that with this minus sign right here. Here I am on Desmos, and once again, I went ahead and typed in our two expressions, and you can see that the graphs are the exact same, so they're equal. Lastly, this isn't much of a manual shortcut, but you will need to know this for certain questions. And that's that two numbers multiplied together will be equal to a times c, and those same two numbers added together will be equal to b. Now you might remember this as the first step in splitting the middle, but when you're doing this, you don't actually need to finish splitting the middle. Anyways, let me go ahead and show you what this would look like. Here I am on Microsoft Whiteboard, and I do have an example for us here. In the given expression, b is a positive integer. What is the greatest possible value of b? Now, as far as I know, there's no ways to solve this on Desmos, so you do have to do this by hand. However, we can use what we just learned, which is that two numbers multiplied together is equal to a times c, and those same two numbers added together is equal to b, which is what we're trying to find. So first, let's go ahead and try and substitute this out. We know that 38 is a, and that 30 is c. So this is equal to just 38 times 30, which is equal to 1140. So if I go ahead and move all this over, we know that two numbers multiplied together is 1140, and those same two numbers added is b. Now first, let's find out what two numbers can even multiply to 1140. We know it could be 1140 times 1. It could be 570 times 2. It could be 380 times 3. And then whatever times 4, whatever times 5, so on and so forth, right? Now we know that any of these two numbers added together could be b. So let's try adding all of these together. Is equal to b. 1140 plus 1 is 1141. 570 plus 2 is 572. And 380 plus 3 is 383. And I think you can notice a pattern here. The further down we go, the smaller our b value will get. Which means that our greatest possible value of b is going to be what's at the very top right here, which is 1141. And that's going to be our answer. Here I have a harder version of the same question. In the given expression, b is a positive integer. If qz to the power of 9 plus r is a factor of the expression, where q and r are positive integers, what is the greatest possible value of b? Now I know that might be like super overwhelming and intimidating. I mean, we're seeing qz to the power of 9 plus r, we're seeing factor, whole bunch of positive integers going on here. And then we have z to the power of 18 here. That's a super big exponent. But it's really not that bad once you take a really good look at it. So let's quickly dive into this. We know that this should be a quadratic because, I mean, we're dealing with quadratics here. So it should look something like the standard form, which is ax squared plus bx plus c. And if we go ahead and quickly move that expression down, 38z to the power 18 plus bz to the power 9 plus 30, you notice here that x squared is in the same position as z to the power of 18. And that x is in the same position as z to the power of 9. And that means that x squared is equal to z to the power of 18. And then x is equal to z to the power of 9. Now that we know this, we can actually just go ahead and substitute in x squared and x into the expression they gave us. So this super intimidating expression can be rewritten as 38x squared plus bx plus 30. And if you notice, that is the exact same expression as the last question. So yeah. And now you can just continue doing your work as normal, finding two numbers that multiply to AC, two numbers that add up to B. And once you get to this point, it's not that bad. Just don't get overwhelmed. I know it's super hard to say that, but just don't get super overwhelmed and try substituting first. Moving on to quadratic functions, you'll need to know three equations. The first one is the standard form, and this is also the exact same as the standard form for a quadratic equation. F of x is equal to ax squared plus bx plus c. And since this time we're dealing with graphs, there's two different things that you can get from this equation. The first one is going to be the x value of the vertex, which is negative b over 2a. And then the second thing is that if a is greater than 0, or if a is positive, the parabola will open up and it will have a minimum value. And then if a is less than 0, or if a is negative, the parabola will open down and it will have a maximum value. Here I have an example, and let's go ahead and find the x value of the vertex and whether the graph opens up or down without using decimals. So first, we know that the x value of the vertex is negative b over 2a, and here b is 5 and a is 1. Remember, if it's just x by itself, there's an imaginary positive 1 in front of it, which means that it's going to be negative 5 over 2 times 1, which is just negative 5 over 2. And then to find out whether the graph opens up or down, we need to look at our a value. And here, a is 1. And since 1 is greater than 0, or since 1 is positive, we know that the graph will open up and it'll have a minimum value. Here I am on Desmos, and I went ahead and typed in our graph, and based on what we just did, we know that the x value of the vertex will be negative 5 over 2, or negative 2.5, and here if we look, the vertex is negative 2.5. We also know that since a is positive or greater than 1, it should open up and have a minimum value, and that is true. Here our graph opens up and our minimum value is negative 2.25. And as you can see, it will always just be increasing. So yeah. Our second equation is the vertex form, and that's going to be f of x is equals to a times x minus h squared plus k. And there's two pieces of information you can get from this. The first one, of course, is the vertex, and that's gonna be hk. An important thing to notice here is that in the equation, it's minus h, which means that when you get the actual number for your ordered pair, it's gonna be the opposite sign. And then just like standard form, if a is greater than 0 or if it's positive, the parabola will open up and have a minimum, and if a is less than 0 or if it's negative, the parabola will open down and have a maximum. Here I am on Desmos, and I went ahead and typed in our graph, and based on what we got, the vertex should be -2, +4, and here you can see it is -2, +4. And since a is negative, the graph should open down and have a maximum, and of course the graph does open down. The maximum value is +4, and then it will always be getting smaller. For our last equation, we have the intercept form, which is f of x is equals to a times x minus b times x minus c. And there's going to be three pieces of information you can get from this. The first one is that the x-intercepts are b and c. And the important thing to notice here is that in your equation, there's a minus sign. So your answer will actually be the opposite sign. Or if it's not like a super pretty number, you could also just set these two factors equal to 0, because this is also just the factored form whenever you finish factoring a quadratic. The second thing is that the x value of the vertex is going to be b plus c divided by 2. And then your last thing is just like with the standard form and vertex form, if your a is positive or greater than 0, it will open up and have a minimum, and if your a is negative or less than 0, it will open down and have a maximum. I just didn't write it because I ran out of space. Here I have an example, and let's go ahead and find the x-intercepts, the x value of the vertex, and whether the graph opens up or down without using Desmos. First things first, we know that the x-intercepts are b and c. Here in this example, that's going to be -5 and -9. But remember, it's the opposite sign, so +5 and +9 are our x-intercepts. Then for our vertex, that's b plus c divided by 2. Here, -5 and -9, but once again, it's the opposite sign, so it's just 5 plus 9 divided by 2. 5 plus 9 is 14, and then 14 divided by 2 is 7. So our x value of the vertex is 7. Lastly, for our a value, technically you don't see it, but once again, just like with the x, if you don't see it, there's an imaginary 1 there. So 1 is greater than 0, or it is positive, which means that this graph will open up and have a minimum. Here I am on Desmos, and I went ahead and typed in our graph. Based on what we got, our x-intercepts should be +5 and +9. And here it is +5 and +9. Then the x value of our vertex should be +7, and it is +7. Lastly, since a is positive, or it's greater than 0, this graph should open up and have a minimum, and of course it does open up, and our minimum is -4, and this graph will always be getting bigger. Now whether you decide to use those little shortcuts on standard form, vertex form, and intercept form, or whether you decide to use Desmos instead, it doesn't really matter. Whichever one you choose, you still get the right answer, so just do the one that you're more comfortable with and you feel like you could do the fastest. Lastly, I do have some tips for word problems on quadratics. The first one is that initial values will be y-intercepts. So if the question said something like, they threw a ball from 10 feet up in the air, 10 feet is your initial value, and your y-intercept will be 10. And then, your minimum and maximum value will be your vertex. So if it said something like it reached a maximum height of 50 feet, then 50 would be the y value of your vertex. Or if it said it reached a maximum height after 3 seconds, then 3 would be the x value of your vertex. So really it just depends what unit they're using, but no matter what, your minimum or maximum will always be your vertex. Alright, that's gonna be all there is on quadratic equations and functions. And I'm not gonna lie, this was a lot as well. I mean, you have these three forms: intercept form, vertex form, and standard form. And then for factoring, you have perfect square trinomials and difference of two squares. But realistically, if you didn't want to memorize that, you don't really need to. I mean, all these really are just shortcuts. So at most, they might save you like 5 seconds. But if you wanted to be lazy, you can just put it all in decimals. I mean, there's no hate here. We all know that I'm the D1 decimals crutch, so like, I ain't hate on nobody. If you really don't care about saving those like 3 seconds by doing mental math instead of putting in decimals, then hey, just skip all of that. But if there is anything that you do need to know, it's gonna be this, alright? Because this you cannot use decimals for. So just remember that two numbers multiplied together is equal to a times c, and those same two numbers added is equal to b. And then also, for word problems, you have these two tips right here. Realistically, I don't think you need to. I mean, if you're like a really good reader, you could probably make sense of it anyways, but this is also pretty useful. Anyways, that will be all, and I'll see ya.